Hi everyone. So we are three here. Okay. So should we start?
Yes, we have to.
Okay.
Prakash sir is not coming.
He can join later.
Yeah, you can start. Yeah, we can start.
Yeah, we cannot be that late because I think we are already 4 minutes late.
Okay. So today I am going to discuss about SSH, secure shell. So you must be heard about SSH, or you must have used SSH. So are you familiar with that term SSH? So Nikhil.
No, ma'am. Maybe I have used, but I haven't heard it.
Yes, but maybe when you connect it to some server, or you need to connect some other machine, maybe a server only. So you have used SSH. I think you have been used that SSH. So
Okay.
okay, so we will discuss about that SSH. So the full form of the SSH is secure shell. So what is SSH? So if we use client, we use client and server, like clients are our mobile phone, our laptops and other machines, which we need to connect over the internet to the server. If we need to open a website, so we send a request through the internet to a server that I want to access this web page, then server sends you that web page. So that's how you access some website. Or if you have to you have a database in your system, or in your university, or in your office, and you need some data from that database. So the database is hosted in a server, but you have to access that database from your laptop. So what will you do? You have to communicate with that server through the internet, and you will access that data after getting the permission from the server. So in this process, the SSH comes into the picture. So SSH is a protocol that allows two machines to talk to each other over a network in a secured manner. So what is protocol? Protocols are set of rules or guidelines over an network. Like how two machines will interact or will communicate over the internet, there are set of rules or guidelines, then only they can communicate with each other. So that protocol is secure shell or SSH, and commonly we call it SSH. So because the two machines are talking to over the internet, so there are some, like there are many people or many other machines or on the internet also. So they can they can hack that communication, or they can get the data. So it is not secure to talk over the internet. So if we need the secure we need to access the other machines data or the servers data in a secured manner, we need to establish some set of rules. So that is called a secure shell protocol. So it works on client server model, as we have discussed. Like client, there is a client and there's a server, and the rules on which they talk over the internet, that is called SSH. So next is historical background. So if we talk about the historical like history of the SSH, so first we need to talk about like how and when we started to communicate through the machines. Like when did we start uh, communicating through two machines? Like earlier we were using only one computer, and we were accessing the data of only one computer and using single machine. Then we felt the need or to communicate with other machine and need to access the data or any other things from the other machines. So we have started the communication from other machine in 1960s. So telnet. So can you identify the sound? Nikhil, can you identify?
Yeah, I heard some sound.
You didn't hear?
Prakash sir is calling. Let me.
Okay. So telnet was a protocol which was used in 1960s. So this sound was of that protocol telnet. So it was a great invention through which the two machines start talking with each other. So before that, we were not able to communicate through two computers. So it was a great invention that we were able to communicate with other machine. So it was very very famous in the computer world. But the problem with this technique was that it directly sends the messages. There was not any encryption or any protocols. So the problem was that it was not secured. So we directly used to send the messages. So anyone can hack or anyone can read those messages. So it was a problem with that telnet protocol. So in 1995, the Finnish computer scientist Tatu Leonin, he faced the same problem. Like he was working on computer network. He was doing some work through telnet and communicating with other machines, and all his work was hacked and used by some other one. So there was a need to develop some secure protocol. So he invented that SSH protocol to communicate over the network. So that was the history of SSH. So SSH uses encryption. So we use encrypted messages to send the information, and we use it uses cipher text using cipher. So we will discuss about ciphers in next part of this presentation. So first we will talk about the encryption. So you are familiar with encryption word, is it correct? So have you heard about that encryption?
Yes, ma'am. In general or in this field?
In general, what is encryption?
Means if we are sending some information in a coded form, it's not obvious. We will have to decode it or get the information indirectly.
Yes. So that is the encryption. Yes, correct. So this is, you can see that a string on the screen. So it is an encrypted message. So we send this encrypted message from one computer to another computer. So how there are some algorithms through which we encrypt the information. So for this, to get this string, I used some simple steps. So I am showing the steps. First, I reverse the order of alphabet in a given word. Second step is reverse the order of words in a sentence. Third step is perform mod 26 after adding 5 to each alphabet. So this is the algorithm. After performing these 3 steps on my string, I got this encrypted string. So if we will talk about the string, the main string was that my locker key is RXLXE. That was the original message, which was encrypted, and then it was shown that in the previous slide I have shown the encoded string. That was the original string was this: my locker key is RXLXE. So the step 1 was we will reverse the order of the letters in each word. So what will we get? We will get ym. If we'll reverse the order of m, ym. Then if we will reverse the order of locker, it will rekkcol, then yek for key. So in this manner, we have reversed the order of the letters in this of each word. After that, second step is, in this sentence, we will reverse the order of words. So what will happen? The last word will come first. So the string will look like this. The last EX, LX, R, it comes first. Then SI is second. Then YEK is third. REKCOL is fourth. And YM is fifth. So we have reversed the order of words. The next step is, we will perform mod 26 plus 5 to each letter. So the place value of E is A, B, C, D, E. So it is 5. So if we will add, we will do mod 26, we will get 0, then we will add 5. So we will get J for that. And similar for that X and then L. So we will get this string after performing this operation. Like for every letter, we will perform mod 26, then we'll add 5. So this is an encrypted string for my locker key is RXLXE. So this encrypted string is being we used to send this type of encrypted messages through the network. So is there any question about that?
Yeah, ma'am. What is mod 26?
Like if we will divide the E, for example, E
It's 5.
Yeah, sorry.
E is 5, right?
E is 5. So we will divide by 26 and then the remainder is 0.
No, so the method is, first of all, you pick up the number. Let's say you pick up 5. I mean, for
Yeah.
E, you will add 5 to it, you will get 10. And then you divide by 26 and you find the remainder. So remainder is the number you get after modular operation. So let's say if you apply it on Z, so Z is 26. You add 5 to it, you will get 31. So 31 mod 26 is just fine. So Z becomes E. Yeah, Z becomes E then.
Yes, that means you are asking about what is mod 26. So it is when you divide something from 26, the remainder is the mod 26. So we were adding. Yeah, you are saying something, Nikhil?
Yeah, okay, I see.
Yeah, so every time when we divide some letter from 26, we will get the remainder, and then we will add the 5 in that remainder part. So we will get this this string. So in E, in case of E, the place value is 5. Then we will get, if we will get we will get the we will divide from 26 and we will get the remainder as 0. And we will add 5 on that. So we will, okay. I'm reversing the order. First, we will add, I have generated this string by adding 5 first and then getting the remainder. So how it comes, 5 plus 5 is 10, and then we will get the remainder 26 is 0. So it is, the value is J. So in the same way, the X will convert it to C, L will be Q, X will be C. So normally, if you will add 5 in alphabets, you will get this string. Like if you will add 5 in E, you will get J, you will get X, and you will add 5 in X, you will get C. When you will go like Y, Z, A, B, C. This is, you will get C. Mod 26 is generally we used to write a computer program so that computer can understand. Normally, manually, we can do directly adding 5 in each letter. So we will get this string. So it is an encrypted string, which we have, we generally use this kind of methods we use to encrypt the messages.
Can you say a few words about it?
Sorry?
Can I say some words about it?
Yes, yes.
About the modular operation. So modular operation is just the, so let's say you have 4. 4, when you divide 4 by 2, you get 2. But when you take 4 mod 2, you will get 0 because the remainder is 0. So by modular operation, you get the remainder. Is this clear? Nikhil?
Yes, sir. Yes, sir. Now it's clear. Previously, I was not aware of this division.
Yeah, it's a very common operation that we study while we study algebra on the number theory.
Oh,
okay.
Okay. So now we talk about another example in which we have we have used numbers to encrypt the string. So the following are the steps. First of all, we multiply each letter's place value by 2. For example, B is having 2 place value, so we will multiply that by 2. So we will get 4. Add 1, 2, 3, 4 to these numbers. These all will not be primes. So if we will add 1, 2, 3, 4 in 4, we will get 1, 2, 3, 8. So then for each blank space, randomly generate 4-digit prime number. So in the sentence, if we will get space, we will generate a prime number, random prime number, and all other letters will not, the encrypted string will not be a prime number. So that is the algorithm which we are using. So it is the encrypted string. So can you decrypt it? Can you just try identifying the how it has been encrypted? We have used this the 3 steps. So can you try? So the hint is like the second one is a prime number, so it will be a space. So the first letter and third letter, there is a space between first and third letter. So in the same manner, you can try identifying what is that string. Any idea?
When we will multiply the place value by 2,
the place value
the
by
first step I'm confused with.
For
Each
example,
letter space value we will multiply by 2.
Yes. So place value means B is having place value 2, C is having place value 3. So we will multiply the place value by.
Okay, this is already encrypted. We will have to decode it, right?
Yes, it is already encrypted.
Okay. I was encrypting this. I was thinking that we will have to encrypt this.
No.
Okay.
We are having alphabetical string.
So we will have to reverse the order, right?
Yes. So all the prime numbers are spaces. We can directly see that. So second one is the prime number, and the other this one is the prime number. So these are the spaces.
These are the spaces.
Apart from all other are alphabets. So okay, I'm showing the string. So I am Richa. This is the string which is encrypted in by using these 3 steps. So the place value of I is 9. So we have multiplied it by 2, that is 18. Then we have add 1, 2, 3, 4 with 18. So we get 1252. Then there is a space. So randomly a prime number we have generated. Then A is having place value 1. So multiply by 2. This is 2. And when we added 1234, it is 1236. So in the same manner, we got this string. So it is an encrypted string. So the decrypted string I am Richa, it is encrypted in this form. So only the three simple steps we have used, and the string is like easily cannot be identified. So these are the simple methods which we have used for encryption. So over the computer networks, the very high and complex algorithms are used to encode the strings, which are not easy to decrypt or decode by anyone. So these are some examples of encryption. So now we talk about SSH. So how SSH works. So in simple language, or in simple words, if we can use example of our daily life. So if you want to send some packet or some gift to your friend, and you want that packet should be opened by your friend only, no one else can see the content or the things which are in the packet. No one else can see that, or no one can open that packet. Only your friend can open and see that packet. So how will you do that? So the method is, you can do the one method to do that is, you will keep one lock on that packet, and you will keep the key with you. You will send this packet to your friend, so no one can open that lock. Now your friend will put another lock on that packet, because he cannot open that lock, because he doesn't have that key. So he will put another lock on that packet, and he will keep the key with himself, and send it back to you. Now you will open that lock from the packet and send it back to your friend. Now your friend is having the lock, his lock, and with his key, so he can open that packet. And he can find out the content or the things from the packet. So in this communication, no one else can open the lock of the packet, because no one else can is having key of any lock. So that is a simplified version of SSH, how SSH works. So there are two-way communication. First, you have sent the key, the encrypted like lock with your packet. Then your friend send the lock from this. So if you are having keys, then only you can open your lock, and if your friend is having the key, then only he can open the lock. No one else can open that packet. So that is SSH in simplified format. So I hope it is clear, like in simple form.
Yeah, it's clear.
Yes. So next we will talk about ciphers. So we earlier talked that SSH use ciphertext to communicate over the network. So what is cipher? So ciphertext is a result of encryption of a plain text using an algorithm which is called cipher. So algorithm are called cipher, and they generate ciphertext. So ciphertext are encrypted messages which we send through the SSH over the network. So these are unreadable by human or a computer without using the proper cipher to decrypt it. So if someone gets the messages, then also they cannot read whether they are human or a computer. These are unreadable until unless they are not having another cipher to decrypt it. So it is a secure manner to send the messages over the network. So there are two type of ciphers we can talk about. So it is substitution ciphers and transposition ciphers. These are the historical ciphers. In the modern technology, we use more complex method for ciphers. But we will talk about these two type of ciphers right now. So the transposition ciphers, if we talk about transposition ciphers, so there is one string from the Parmanu movie. In the end, they send the message that White House is collapsed. So that was a message they sent when they did that that blast. So how the transposition cipher works? So we will use that the White House is collapsed. So if we want to use, we will use the cipher key to encrypt and decrypt this string. So if we want to use 5-digit cipher key, we will create a matrix which will have 5 columns, 0, 1, 2, 3, 4. So this matrix is having 5 columns. Rows can be like any number of rows can be there, because it depends on the message or the number of alphabets. But the columns will be same as the key we want to use for encrypting the messages. So we are using 0, 1, 2, 3, 4. This is a matrix. So we will arrange this string in this matrix. So basically, transposition cipher is what? It is rearranging the order of the letter of a string. For example, like the White House is collapsed. The letters will be same, but these will be rearranged in a specific manner. So how will we do? We have created a matrix. Then we will put this string in this matrix. So THEWHITEHOUSEIS. So like we have placed T on the zeroth position, then H on the first column, first row on the matrix, and then E on the second column, first row. And in the same way, we have placed this string. Now we have used the cipher key like 20413. This is the cipher key. So what it means, if we will use the second column's digit first, then we will take 0th column's digit second, and then 4th column's digits, letters, then first column's letters, and then third column's letter. So how will we get the strings? First of all, second column's letter. What is the second column's letter? EEELE. So we will get EEELE. Then 0th column's letters, TIUCP. So that will be TIUCP. Then 4th column is HOSA. So HOSA. Then first column is HTSOS. So we will get HTSOS. Then third column is WHILD. So WHILD. So we have rearranged the order, rearranged the letters of this string. The White House is collapsed. So we get this encrypted string in transposition cipher. The cipher key is 20413. So this is one method of getting the cipher text. So is there any doubt, Nikhil?
No, ma'am.
Okay, so this is one method. The next
is there any difference between encryption and ciphering?
No, encryption is very common term. Cipher is a cipher text. Like it is more, we can say there are more complex method to encrypt the web. So it is we can call the algorithm is a cipher, and the text which we get is a cipher text. Encryption is very common. We use in many things encryption word, but cipher is specifically for a communication in network.
Okay.
So substitution cipher is like we substitute the letters with some other letter. So we already have taken the example of substitution cipher, like the White House is collapsed. So we can replace all the letters with some other letter. For example, we can add one to each value of letter. So T will so we will get this. Then a modular operation is applied. Okay. So in the T we will add 1. So we will get U, and modular will be 0. So we will get U in the same manner. H will be I, E will be F. So we have added 1 on the each letter. So we have got that string, as we have seen in the previous example. So this is substitution cipher. So these two methods, transposition cipher and substitution cipher, are the historical methods. We in the modern days, we use more complex algorithms and modern techniques to create the cipher text and like the more complex ciphers. So we will talk like in future about that, but in this presentation I have not covered those modern techniques. So these are the simple method of ciphering the text. Now we will talk about the cryptography, method of cryptography, because in SSH we use encryption, we use cryptographical methods. So there are two methods. Basically, like in broad way, there are two methods: symmetric key cryptography and asymmetric key cryptography. So what is symmetric key cryptography? We use, like as a name suggests, symmetric key. The both server and client or both the machines are having same key. This is the shared key of key between them. So shared keys are used for encryption and decryption. So you are having a laptop and you want to connect with some server. So you will have one key and the same key will be with the server also. So when you will send the message to the server, you will encrypt the message using your key, and the same key must have with the by the server, and he will decrypt the string with the same key. So it is called symmetric key cryptographic method, in which the same shared key are used by both clients and server. So we generally use this method for example, in online payments, when they need to identify the user by using some IDs. So they use the symmetric key cryptographic method. And in any other many other also in many other things, we use that symmetric key cryptography method. Next is asymmetric key cryptography. So it is also called public key cryptography. So public key cryptography means there is one public key which can be shared with anyone, not from that client, any other can be client. So multiple computer can have public key, but the pair is a shared public and private key pair is used. Like public key can be shared, but there will be a private key paired with that public key, which should be only with that particular client. If he is having that private key also, then only he can connect with the server. So it is public and private key pair method. In the previous method, only one private key and one other private key will are used to both the machines. But here there is a public key which can be shared with other systems also, but there is one private key associated with that public key. So so that only authenticated system can get the connection with the server. So we use in this method in SSH and data encryption. Generally, we use this method in these type of services. So basically, symmetric key encryption is quite difficult to establish, because there are two keys only, and we have to secure these keys, and we have to keep the private keys with both the servers. So this method is quite simple comparative to symmetric key method, because one public key can be shared with anyone. So any number of clients can be comes into picture, and then we can authenticate few of them. So how SSH works? Now we will talk about SSH. So first of all, it uses asymmetric key cryptography. So it uses public keys and private keys. So how it use? First, client shares the public key to server, and server identifies the public key in its file system. So what happens? if you want to connect, like my laptop, I want to connect with some server of my, for example, if I have my company's database, I want to connect with my company server. So I will share I will have a public key. So because already my laptop has been authenticated by my company. So I'm having a public key. I will share that public key to my company server, and that server will identify the public key, whether it is present in its file system or not. If it is present in its file system, if it finds public key in the file system, then it generates a random string using the public key. So it will generate a random string. The server will generate a random string, and it will encrypt that string using that public key. So that string will be encrypted and it will be sent to me. So what it says, it then sends the string to the client. So the server generates that string and encrypt it, and it sends to the client. Now client is having a private key that is a pair with that public key. So I'm having a private key that is paired with that public key. So only that private key which I'm having can decrypt that string. No one other can decrypt that string. So if over the network anyone hacks that string, then they cannot decrypt that string. So only I will be able to decrypt that string. So I will get the string, like client will use that private key to decrypt the string and sends it to server. So what happened, I get that string and I decrypt it and sends back to the server, my company server. If the string matches, then server authenticates the client and a tunnel or a connection is established. So I send that decrypted string to my company server. The server matches if the string is same as the string which he sends to me. If it is fine, like I am an authenticated client, so the server allow me to connect with the database. So a tunnel is established between client and server. So there is a tunnel between me and between my laptop and my company server, and the client and server will communicate with each other using encrypted message through this tunnel. So now we will use that tunnel to communicate with each other, and we will send that encrypted messages, and we will be able to decrypt that messages using our public and private key. So that's how the SSH works, and that's why it is very secure. So the basic thing is, like, I am sending some keys to server. Server is sending some random string to me to me to authenticate to me. And if I can decrypt that message and it is correct, then only I will be able to connect with the server, and then I can communicate to the server in a very secure way through a tunnel. So that's all about the SSH. So that's all for today. So thank you for your attention. So I think, is there any doubt or is it clear?
Can we have an example for the last slide?
Example of SSH, like
Yes.
there are some commands I need to write, or we have to establish a connection. So I can tell you verbally, because in this computer maybe I will not able to show you the how.
No, verbally only means like the client is first generating the public key and the server is then sending the public key, and again the client is using the private key. An example is there, like till the 7th point I was thinking it's like if I am asking my bank detail to the bank and then he is sending me a PDF file and I'm using a password and then I can see, I was thinking, but as soon as the 7th point came, I thought my example was very different and wrong. So I don't know.
Like in the banking system, you should not relate with it. It is with banking system. There are some different techniques also, because you are using their sites. Websites are having different protocols. In the SSH, you can imagine, if you want to you want to take some code from your some server. If you use, if you want to take some data from your data, like if your university your university is having some database, and you want to access some data from there. So first of all, you have to already authenticate with that server, then only you will be able to connect with server. So in the starting, when we registered with the system, they will authenticate with the authenticate us, like they create connections of our laptop, like they take the IP of your laptop and they register it with server. Generally it happens. It's, I don't know in your field it happens or not. So basically they generate some keys, and that these keys are with the servers and your system. So your system is having private public key and the shared private key with you. Now you want to connect with your university's database. So you will write SSH, and then client, like your server name, you will write your server's IP address. So then when you will do SSH, it will try to communicate or connect over that IP, the IP of the server you will write. So that machine, it will try to connect. So it will send a public key with it to your university's server. Now your university server will check that public key if it is present in its file system or not. If it is present in its file system, then it will randomly generate a string and it will send to your computer, and your computer will decrypt it and it will send it back to your server. So you can't see this process. It happens internally. You will get the connection is being established. You will get that screen only. In any case, like if you will use putty, you will have to wait some time. So internally it is happening. And if you are using some Google Cloud or anything, any other thing, AWS something, they will also use SSH. So you will get the message that it connects, transferring SSH keys, or you will get the message a connection is established. So you will not able to see that. You will only SSH the things, and you will provide the authentication password or ID and password, which is being used to register your laptop with your server. So you will only provide your credentials and you will SSH that. Internally, the client and server is doing these things. So if you are you are trying to simulate the things with banking payments, so you will not able to see anything. It is doing internally. You are giving only password and ID, and in banking system you are using website, so multiple protocols are comes into picture. So it is directly not SSH is you are using SSH. So you will not able to see like how the keys are being transferred. It is the internal mechanism. So was that the answer of your question, or you are asking something else?
Actually, I was asking that example which I can understand. Like you asked that if we are using the university's internal, what should I say, server, like if we are connecting through the IIT in Wi-Fi net access, then we can only access some files like our hostel dining site or our internal sites only we can visit. Otherwise, outsiders cannot visit that sites. So we have some internal sites. If we are using, if we are asking any information from these websites, that is called public key.
That is not called public key. You are already registered with like you can say like the system is like that only SSH. You are using SSH and you are having all the students of IIT Madras are having some public keys in their laptops. They send that public key to your server, and then your server decrypts it and sends it back to your laptops, and your laptop the server of IIT Madras generates a string and it encrypts that string, and then it sends to your laptop, and your laptop is having private key also. So your laptop decrypt that string and then sends back to IIT Madras server. Then if because you are having correct private key, then the decryption is correct and you are able to connect with that server because it authenticates you. but some outsider in its laptop, the public key is not there and private key is not there. Anyhow, he can get public key. It is very easy to get the public key. So he will get the public key. He will try to connect to IIT Madras server. Okay, he will send the public key to that server. First of all, your server will not get the public key if it is not correct, but anyhow he get the right public key, because public key can be accessed by many people. So IIT Madras server will get generate a random string and encrypt it and will send to that outsider laptop. But that outsider laptop will not have any private key paired with that public key. Only your laptop or any any student, every student of IIT Madras which are configured with that server, only they have that private key, but outsider is not having private key. So the server, he will not able to decrypt that string and he will not able to send it back. So server will not authenticate that outsider's laptop and he will not be able to connect to the system. So how, this is a method how it works.
Okay.
So any other doubt?
No, ma'am.
Okay. So anyone else is having any doubt? Or should I stop sharing?